I want to welcome everybody to this presentation today. My name is Dave Bittner. I am the producer and host of the CyberWire podcast, daily cybersecurity news podcast. A few things before we get started today, before Jason Christopher begins his presentation, just some housekeeping things here. This webinar is being recorded, so if you have to drop out or you want to catch a rerun of it, it will be available later. The recording will be sent out, so that will be available. We ask you to submit your questions via the Q&A feature, and we'll be going through and addressing some of those questions at the end. And also, please have your phones muted so that we don't inadvertently have you become part of the presentation. With that, it's my pleasure to turn things over to Jason D. Christopher. He is a Principal Cyber Risk Advisor at Dragos. I'm going to let him take over and fill out the rest of his resume. Jason, the floor is yours.
Thank you very much, Dave. So I always get a little bit embarrassed when doing my own bio slide, and I get embarrassed even more if Dave were to read it. So what I really want to just be able to highlight is I've been lucky enough to have a variety of different roles over my career, focusing from being on the industrial side of things, so actually installing what we're going to identify as industrial control systems, sort of the critical infrastructure that we use within the world to be able to really power our way of life. I'm also a SAN certified instructor, so I teach 5-day courses on securing those industrial systems. And previously, I've been a CTO at a company called Axio Global, where I worked on risk management conversations that highlighted what I did previously for the federal government, working both as a regulator and for the U.S. Department of Energy, really identifying ways to manage risk, ways to talk about that from a cybersecurity perspective, so that when we discuss cyber risk, we're not just saying things in terms of red, yellow, green, but actually mapping it back to things that people are worried about from a company and critical infrastructure protection perspective. So what are the things at the end of the day that we really concern ourselves with from that side of things? So just a smattering of things that I've had over my career, just to basically say, I've done a lot of cool things, and I hope to be able to share some of that knowledge with folks on the call today. Today's focus point is going to be ransomware in an industrial world. So as the tagline really is talking about, I'm going to focus mostly on those industrial control systems, the operational technology side of things. Not knowing necessarily, with over 1,000 folks joining the call, where everyone sits on the IT side of the fence versus the OT side of the fence, versus what I'm doing for engineering, or am I focusing mostly on ransomware, and do I want to talk about threat stuff? So this call will really focus on a lot of things at a sort of base level setting, that we could talk about things from a what is OT, what is a attacking industrial control system look like, and then where does ransomware fit? We've heard this come up time and time again. We've dealt with it for many organizations in the real world instance. So when we talk about those recent events, what does that mean for those industrial control systems? The things that power ourselves, the flowing of power, the flowing of oil and natural gas, water, things that we are really reliant upon, so that when I turn on the light switch, the power comes on. What does ransomware mean for that as well? And then lastly, because I really hope that there are folks that get sort of actionable guidance from things like this, as opposed to just saying, look, all these bad things are happening. I want to be able to talk about some sort of actionable things that we can do, recommendations for those who are actually doing security in industrial control systems to be able to power things forward. So when we talk about industrial technologies, we really are focusing things that are industrial control systems and operational technology. They differ from IT, the traditional IT things that we're thinking about, email, what we're doing for data centers and things like that, where things instead looking at 24/7 operations. Are we creating something on a batch assembly line? These are things that have 10 to 30 year life cycles when we deploy them. So if you think about having an iPhone for 10 or 30 years, you're already ahead of the curve, because a lot of these things that were deployed 10 or 30 years ago weren't of that type of technology curve that we think of an iPhone. These are typically, I would say, more dumb devices than we're used to. And as a result of that, we really need to worry about protecting them both from a perimeter perspective, as well as hardening as best we can. When you're deploying something on the life cycle of decades instead of years, there are going to be a lot of organizational constraints that come with that. And when we think about it, we're thinking about in terms of, in the United States, we define them as 16 critical infrastructures. These sectors will range from anything from, as I said before, energy, power, to things that are including commercial manufacturing, to other things such as the healthcare sector. So those are all things that we think of when we think of industrial systems. And tying those things together from an overall perspective is they share the same DNA when we think about operational technology. If I take something that is a controller that is actually controlling something in the real world, it will look the same in each one of those sectors. It's just the thing that it's doing may be a little bit different. The controller that is running a conveyor belt is the same controller that I'll see in a substation, but what they do in the real world is just have a different type of impact. So when we think about industrial control systems, what I want folks to think about, especially if you're coming from an IT background, is where a 0 and a 1 will actually impact something in the physical world. So these are things like motors, sensors, generators. We'll talk about safety systems in a little bit because there have been attacks on those as well. Field devices, anything that's taking an input and an output, very simple level machines that then may have that human to machine interface. That's where we see sort of those antiquated Windows computers. You'll still see Windows XP in these different environments where an engineer is actually putting in the logic that then controls what's happening with that motor or with that generator as a result of those interactions. And over time, we have gotten more connectivity into the operational technology space. Compared to where we used to be, where an engineer would be on site actually operating the things themselves, to then introducing more logic for the sort of these relays and different connectors to be able to figure out, oh, what type of data am I getting? And then what type of new output should I do as a result of that? It's a feedback loop. The sensor is sensing something that's happening, and then it's going to change as a result of that. The easiest way to think of a control system is actually your thermostat in your house. If you go over there, you put in a set point of what you want the temperature to be. There's a sensor that discusses, well, what is the temperature right now? And then it's controlling whether it's your air conditioning or your heater to get you into that nice set point that you set it for. Very simple. We don't go in there and talk about, I mean, we can talk about Nest thermostats later if people have questions about it, but we don't talk about, for example, having antivirus on that thermostat or having access control on that thermostat. So as we introduced more technology to this, we didn't necessarily have that security perspective going into it. So now where you can see we're talking about sort of Industry 4.0 or IIoT, the Industrial Internet of Things, where we're talking about connecting those things more together as a result of getting better optimization. That's really when we talk about connectivity, what we're trying to sort of see from a business side. The Industrial Internet of Things, as an example, is a conversation about optimization and optimization of flows. And we're connecting things that haven't been connected before as part of that optimization problem. So doing it securely becomes one of the big things that we're worried about going into the future. The other curveball, as I've already kind of alluded to with the thermostat example, is that the things that we traditionally use in IT security don't have the same type of impacts that we would hope for in OT. Encryption, for example, could add latency to a process. An engineer may need to be able to see that data and have visibility for that data and not have to worry about a 1 millisecond delay as a result of encryption on those systems. Patching, one of the things that we routinely talk about within IT, and then OT, that can lead to outages. We talk about really trying to lock down ports and services, and a new patch can open things up, and we have to test those things out to make sure that, again, the physical world doesn't have those sort of negative impacts. Antivirus, those would be incomplete system monitoring. There's a lot of things that we want to be able to check for in OT processes. They're a little bit different than what antivirus can give us a protection for. Vulnerability scanning, one of the very first things, if you just go into an OT network and if you run a simple command like Nmap where you just want to be able to see things, you may actually crash that system. Because these things are deterministic, they are looking for a 0 and 1, and when they don't get that 0 or 1 they're expecting, they may look at you cross-eye and fail over, in which case now you have a maintenance event that you need to be able to take care of. And then endpoint agents, there are a lot of devices out there that are just not capable of taking those things. So the traditional sort of IT security best practices that we'd expect to see don't really work for us in the OT side of things. So we have to be a little bit more creative when we talk about what we're doing for security in those spaces. Real world cyber-based industrial impacts. So these are all things that have happened. There are plenty of documentation on these. I'm actually avoiding some of the big names in here. I talked about a 2009 centrifuge failure. Wink, wink, nudge, nudge. We're talking about Stuxnet in that case, right? These are things, again, that when you think about the impacts, The impacts are not what are we doing to process credit card numbers or social security numbers. It's not something I worry about when I'm operating the grid. It is something that I'm worried about when I'm talking about billing data, which is the separate side of the system that I'll introduce later. But this OT side is, again, very focused on physical processes. So when we think about what type of bad things can happen here, we can talk about sewage spillers, the Mushi Shire incident in 2001. 2014, German steel mill that lost control of the actual furnace itself. 2015 and 2016, the outages that happened within the Ukraine, all were cyber-based attacks that focused on the OT side of things. And then 2017, one of the big things that we've been talking about very recently is the target of safety systems. Within this conversation of a piece of malware called Trisis, we were then seeing safety systems get targeted, which, as the name implies, our engineers really want to know when they go on site to respond to something, they're going to be failed safe. And when you can't trust that safety system, now we're bringing in things that aren't just property damage, but also potential harm to human beings beyond environmental impacts, property impacts, and things of that nature. So what does this all break down into? For those of you who are familiar with the Lockheed Martin cybersecurity kill chain, this model is that model exactly. So we talk about how you build a campaign for a cyber attack, starting off with reconnaissance, finding out more about the organization that you're going to target against, weaponize an attack, find out who's going to click on that phishing link, deliver the actual malware, exploit, install, sort of get to command and control going back and forth, and then just own that organization. We're going to describe this as the IT-centric part of building a campaign that you'd worry about within the ICS infrastructure. It doesn't consider, well, what would I do for having a sewage spill? Or how would I fail a centrifuge or have an outage as a response to what I'm doing? It's largely considered for us the stage one of what we're going to define as the ICS cybersecurity kill chain. Within that, you're still going to do this as part of what you do to target an actual industrial organization, but it's focusing primarily on the IT side of the equation. On the OT side of the equation, we now need to know more about the skill set that the adversary may have. They need to know a little bit more about ICS protocols. They maybe need to know about the engineering process that you're worried about. There's going to be a specific set of skills that need to be developed as a result of that go beyond the typical stage one of that kill chain, what we've already seen from Lockheed Martin and others. So in here, you can see that there's a new capability tailored specifically to an ICS implementation, testing what that's going to look like. You don't necessarily know when you create a piece of malware that will go into an OT network what it's going to do. You need to have some sort of testing before you get to that piece of things and then deliver it into the OT system. And then sort of enable the ability to execute that attack and figure out whether or not you're going to have this overall loss of the control system as a result. Are you losing visibility? Are you manipulating the process stream? Are there things that you're doing to the engineering piece of stuff that really matters? So stage two discusses those unique capabilities within ICS. And that's how we're going to think about things when we talk about ransomware momentarily. Because the overall industrial attack is both IT and OT. We have this stage one attack. This is your corporate IT network, right? These are the things that we'd expect to see from that reconnaissance phase to being able to have a phishing campaign. Somebody clicks on a bad link. It gives me more information about the organization I may be targeting. If I'm a utility, maybe I want to know more about the power flows that I'm targeting when I'm an attacker. Maybe if I'm targeting a water organization, see if I can get any project files that may be on there with regards to the OT system, because that stage two of things needs to blend together. You're going to see attackers who are building this capability figure out a way of flowing down from their stage one attack into something that they may have created for industrial control systems. Where that plant OT, that operational technology piece, you can see here at that very lower rung, that's where we see those what we call level 0, level 1 devices, sensors, things that are dumber, right? They don't have the same sort of information I'd expect to see on an engineering workstation even, and certainly not what I expect to see on my iPhone. These things are going to need a lot more protections at that perimeter than anything else. But that stage one could bleed into the stage two, meaning that the stage one could have attacks that go down to that firewall that's happening at that plant OT environment, where that attacker may be looking at things that are happening on the engineering workstation, but they don't know ICS protocols. in which case they're not really going to be able to give you that physical impact that you'd expect to see from a true industrial control system attack. And I use that phrase meaningfully. When we talk about attacks in industrial control systems, we're talking about something that's impacting the physical world. It's not something where we can say we have 5,000 attacks a day. It's not something where it's just how many pings do I get off that firewall. It's somebody who actually has knowledge and capability to do something in our control system to cause losses of property, casualty, things of that nature. All right, which brings me into what are those targets looking for? They're looking for sort of that loss of view or control, manipulation of view or control. If you can't trust what's going on in your control system engineer, I see a set point there. I have my thermostat. I want to make sure that it's 68 degrees, but all of a sudden somebody has made it so it looks like it's 68, but it's really set for 80. That would be the sort of manipulation of view where it really does require an additional knowledge beyond just, well, what do I make this thing look like? What is the engineering process that goes beyond that that can make this thing break a little bit more? So for ICS specific capabilities, the impact would be, again, focused on the operational impacts. And then lastly, before we get into the real crux of the ransomware conversation, the ICS attack difficulty. Here, when we talk about the knowledge involved is really what I want to focus on. Compromising the ICS security, as you may have already figured out, if we're talking about securing thermostats, that's going to be relatively easy, right? Think about those on an industrial stage, right? Gigantic furnaces. I often joke that if I wear the right hard hat and the right, polo shirt, how far can I get into a plant? Probably pretty far. Compromising the ICS security may be a relatively easy thing for an attacker to focus on. But if you can see here, having high confidence as to what the process in the industrial control system is actually doing and executing an attack that would cause a failure that you know is going to happen, that requires, again, some sort of combination of your IT security expertise, your OT processes, what your engineers may know, as well as how is this organization going to respond and recover. The response and recovery aspect of OT is a little bit different. If you see something that is on, you may want to leave it on, even though you may be dealing with an attack somewhere else. Trying to make sure that the process and the safety and the reliability comes first is what you're responding to. So now that I've level set, hopefully for those of you who are not OT folks and industrial control systems experts, you now have got a little bit good understanding about what it is we're going to be talking about when I think of ransomware in industrial systems. Ransomware has been everywhere, right? We've been talking about this in the news now for years, and we've seen an interesting evolution as a result of that constant use of ransomware within different environments, not just obviously industrial, mostly focusing on the IT side. In pre-2017 timeframe, we're talking about primary targets via phishing, going to a bad website. It was single victim though, and single machine focus, right? So somebody clicked on a bad link and it was that machine that was infected. From 2017 to 2018, we started seeing the rise of the worms, right? We started single victim, still, phishing, malicious websites, but then it was opportunistic targeting, finding out who within the organization would be most likely to be able to not only click on that link, but then where do they sit? Could the attack propagate, and how would the attack propagate to be able to have more significant damages on that IT, that stage one side of the equation still? And then in 2018 to today, seeing sort of this interactive operations that attack whole corporate networks and hold your corporate networks hostage. So we're going beyond the, can I infect as many machines as possible and infect widely, to where are those network devices sitting? Can I actually get to an entire system in a knowledgeable way and exploit that? So this evolution has happened over a series of years. I'm not going to really focus in on the pre-2017 stuff. There's a lot of good conversations about the rise of ransomware that we've seen from the FBI and from others that have released reports. What I really want to focus on is what we're seeing from 2017 to today, and how that has sort of caused this chaos almost in what we do in ICS. So the first one to focus on is going to be Wannacry. So I love this interactive map that came from the New York Times. You can see the little link right there if you want to be able to look at it yourself. This shows you the propagation of how quickly this thing enacted itself. It hit 230 organizations in over 150 countries in a matter of hours. We've never seen anything at that time that moved that quickly, that fast. It was stopped by a gray hat hacker who had done some interesting work in the past and had actually found that the registry for the kill switch was not registered themselves, and just dismantle the whole thing simultaneously. If it weren't for those actions, that would have taken a much longer time to recover from, and it would have hit a lot more organizations before we'd gotten there. You can see that a lot of the attack had happened for us before we'd even gotten to lunch here in the United States. Focusing, interestingly, when I was sort of figuring out the best way to have this conversation, I can't have a conversation about industrial control systems in this space without talking about NotPetya. But NotPetya is not ransomware. It is this great quote here. It's a wiper disguised as ransomware. It had collateral damage for industrial control systems. So you can see that there was a lot of conversations here that took place. There's a lot of good written articles here over the overall impact here. We'd seen almost immediately FedEx had responded saying that they was looking at $300 million worth of damages from NotPetya. Regardless of ransomware or a wiper, and this is sort of where I sit within Dragos, I think more about things from a defense side of things. We have a great intel shop that goes really dives deep into what these things look like from an attacker perspective. From a defender perspective, whether it was a wiper or ransomware, my response is looking a lot the same. I'm immediately trying to figure out how do I get back to operations, and I'm not going to necessarily chase down all those aspects of the adversary. I love the fact that I work with such smart people that can do that. But for me, when I'm talking to clients and people who are still operating things, it's really figuring out, well, what would we do during this really bad day? You can see here, what do FedEx, Maersk, Mondelez all have in common? Conversations that's taking place is that they happen to file taxes in the Ukraine, and the propagation of where this came from, sort of hitting multiple organizations globally. From having something that was built into tax software that then hit all these organizations from different ways that may not have been the best way to identify where their security gaps were within their programs. And you can see that we're still talking about this today. This was actually just in 2018. We still have a lot of people who are talking about from the insurance side, where the insurance payouts are happening. But we're looking at something that's over $10 billion in estimated damages across multiple organizations. We had 2 million computers that were impacted in roughly 2 hours, and there were over 65 countries that were involved in some sort of response criteria as a result to NotPetya. So again, not ransomware. There wasn't a conversation about you being able to pay the ransom. It was definitely, once you got hit, there was no way, the way the malware was formed, it was wiping things out. It was not giving you the ability to decrypt and be able to get back to operations using that. But again, your response may or may not look more or less the same. I'll talk about that when we get to recommendations later on. Then getting into very recently conversation about Nevsky Drone. So very interesting. If you look through what was happening there, I really love the fact that Norsk was very open with what was happening to them at the time. So they talked about how you saw this at execution, it removed itself, it launches a child process, it wrote you a ransomware note, being able to talk about how they were able to exploit you via the fact that you didn't have a great security program in place. And then it started to encrypt the files and binaries and started to change local user and admin credentials. That got a little bit more interesting now. So now it's starting to change all these passwords, and it disabled the network card and then locked out everybody who was already logged in and changed your password so you couldn't get back into it. Your recovery aspect of that point becomes nightmarish. It's not then just talking about the fact that we've locked down your systems. We've locked down, again, your entire network. So being able to talk about your operational perspective, if this bled down, if you did not have good perimeters in place between IT and OT, you could absolutely see how this could impact operations. But even if it didn't, even if you had like the strong boundaries between your industrial control systems and you're only worried about the IT side of the equation, IT side of the equation for this, for your organization, imagine being blasted back to the 1970s. You can't make emails, right? You can't write anybody talking about this incident. If you have voice over IP, you can't call anybody. So all the things that you typically respond to are no longer within your tools and kits that you could use to roll out a flyaway team to be able to get them there. So I want to stress that as well. When I talk about where this looks like for industrial control systems, it may just be that you didn't have the right perimeters in place. It may be that there are different conversations about impacting those Windows XP machines that we didn't secure properly down in that OT space. That would definitely have a lot of damages as a result of that. You'd have things that would fail. You'd have things that you're locked out of, but your processes may be okay. It really would depend on your architecture. But if your IT system is also down and your engineers now can't communicate with headquarters, that could be a really bad day that gets sort of exemplified even more. So again, the focus here is that the conversation we're having is that OT becomes almost collateral damage to the things that are happening in IT. When you talk about ransomware within industrial organizations, nothing that I just described highlighted that they had anything in that stage 2 capability. We're not talking about ransomware in the cases that I've already highlighted. We're not talking about ransomware that had the idea to understand what is an engineering process. What are the zeros and ones that this controller or this generator or this industrial grade furnace can understand? It's really trying to lock down things that are happening on the IT side, and that may have bleed over. That may absolutely have bleed over into your OT networks if they're not properly sort of gapped between, secured in between those two networks. But overall, again, we're not talking about industrial processes specifically having ransomware targeted at that. Or at least I would continue to say that. There's a great report that was released recently about Ekins that actually showed it was looking for ICS-specific processes, file processes, not the engineering stuff per se, but it had a little bit of understanding there. And so we've seen things that were happening in late 2019 that demonstrated some sort of knowledge of what may be happening in OT. Again, not looking that it's shutting down OT processes, it's not having a specific capability down there, but we're now seeing pieces of malware that may have interest levels as to what's happening in industrial processes. So this slide is really just to help out with what considerations and trends we're looking for going forward. And that's one of the things that's definitely popping up on our radar. The fact that we may have ICS-specific things now popping up in what's traditionally that IT side of the equation for ransomware. Ransomware is also equal to real dollars. And so it's one of the reasons why we see this continually pop up. I know that we talk a lot about nation state adversaries, and we absolutely need to be concerned with highlighting the threats from those and be able to manage those, especially when we talk about critical infrastructure. We need to make sure that for civilian infrastructure, we are not dealing with nation state adversaries in our systems. But where these organized crime organizations come up and where they're looking for that real dollar spend, by being able to craft malware, they're able to get money. And so the interesting thing here is really, do your organizations know what they'd be willing to pay? Has anybody talked to them about would they pay the ransom or not? We had a couple of headlines recently that I'll highlight in a moment about, well, what does this look like from that paying perspective? And what would you be willing to pay if it was your whole network that was down? Or what if it was your entire industrial plant? What is the value of that? I know many organizations already know what the value of 1 day of downtime is in their OT plant. What would that look like, and how would they be willing to pay as a result of that? And I think that's one of the things that could be concerning about folks focusing on industrial control systems. I talked about this a little bit, ransomwares versus wipers. While there is the nomenclature difference between creating that malware and the targets of those malwares and why they would be created, from the blue team side of the fence where we are actually responding to these things, I'd ask folks, would you change your behavior, whether or not it was ransomware or a wiper? Very similar to, again, would you pay the ransom? If you're not going to pay the ransom, then you're in almost the exact same spot, right? You're rebuilding your networks, you're rebuilding your devices, you're rebuilding processes. If you do pay the ransom, then my question would be, would you ever trust that system ever again? An attacker had already demonstrated they're able to get a foothold in there. Would you ever have trust of that computer again, of that network again as a result? And then sort of overall, what's next? Ransomware evolution over the past few years have been really big on impacts. So I want to get to recommendations, but I wanted to highlight this before I got there, and then we'll close this out. Whether or not you pay the ransom or go out of your pocket, this is one of the things I see people comparing themselves to. And I had a Twitter poll that was not so successful about asking people, did you actually think through these things? You hit ransomware, Florida City agreed to pay $600,000, whereas Baltimore has an estimated $18.2 million impact. Those, when you talk to executives and you're trying to talk about the risks that we're facing here, are real big different numbers. And being able to have a strategy to talk through this is really important, I think. Because again, even if you pay the $600,000, would you be able to fully respond and recover? And we now have mayors, US mayors, 22 of them signed a letter saying that they will not pay the ransom if they were to be attacked. So municipalities at sort of that lower level of government are taking this very seriously as well. All right, so now I give everybody all the good news, all the fuzzy wuzzies of the things that are happening in the world of ransomware. I want to close out with a couple of comments about what we do from an overall protection side of things. That's my background. I talk about a lot of security standards that we can put in place, what requirements are really important for you being able to minimize the impacts that we see in industrial spaces. And it all comes down to protecting your crown jewels. You want to be able to know what that bad day looks like. And you also want to be able to figure out, well, what are those systems that would cause those bad days? And you put your investment, you put your protections on those things. If you're just getting started on industrial security, if talking about the kill chain was new to you, if talking about the zeros and ones impacting controllers and generators and things of that nature was a new topic, but you have something to do with an industrial organization, it may not be uncommon for a lot of folks starting this journey saying, the engineers have it covered. The OT team is securing the network just fine. I guarantee you that 9 times out of 10, that OT team may not have been able to identify security standards to put in place. So dedicate OT specific resources. Who knows how to protect the industrial control system? Who knows that you don't want to be able to necessarily put a whole bunch of different solutions on there from the IT space that won't make things crash. You can do this in-house. You can train folks. You could also do it third party. Whatever it takes really to understand the system is the very first piece of this. And then plan for that bad day. Who would you call? That's the number one thing for engineers, right? And not necessarily have them doing their own threat profiles and figuring out like all the bad things happening, but they do need to know who to call if there was a bad day. And then what to do if you can't call somebody because we use voice over IP and that whole network's down. Well, how do you have that conversation with everybody from an incident response perspective? And then understanding those impacts. What does that really bad day look like? You really want to be able to identify those crown jewels to then invest in what those protections would be. Those protections would start off with investing in perimeters. We have a conversation in industrial control systems where we call it the M&M model, the candy, not the wrapper, hard shell GUI center. We invest a lot in the perimeters because these controllers, these industrial, grade things that are like your thermostats, can't figure out who logged in necessarily. They have sensors that just be able to get zeros and ones, controllers that act on those things. There may be a human machine interface to be able to get engineering inputs, but by and large, you really need to be able to make sure that the investment in the perimeters comes first and foremost. Restricting those external communications. You always hear people talk about the air gap. The air gap is usually a myth. Your vendors will almost always have an external communication into their very expensive $250 million turbine. You want to be able to make sure that you're managing those and know what's happening in those. And then look for the bad stuff. Having some sort of OT monitoring that you're able to look at that, again, looks very different than IT stuff. Those protocols are 30-year-old protocols that we depend on for reliability and safety. We don't want to interfere with them, but we want to be able to get good data back where we can. Strengthen and harden your systems. So your mileage will vary there. It depends on what type of assets you have in the field, what type of controllers you have, what type of outdated piece of 30-year equipment you may or may not have. And understand that last known good state for all of them. Really having almost a baseline there. What are your set points for each of those? Do you know how to get to that good state again if you had to? And note that these things are in a high trust zone. I just did a quote for NBC about what we're all doing about coronavirus. And I was quoted as talking about the dirty, dirty internet, not touching our clean, pristine industrial control system environments. You want to make sure that those things are absolutely in so the highest trust zone as possible. And that may include annoying things like you can't plug your iPhone directly into a controller or a human machine interface, right? You want to be able to make sure that you're keeping that trust within that zone as critical as possible. And then I don't think this is a surprise to anybody that a ransomware talk would end with backups, but backup where you can. You may not be able to back up all the things in the way that you think you can. You may have to take some paper down for what your set points are, Excel profiles, spreadsheets of all these different type of things. But when you think about those backups, think about what you do for hot and cold storage. If it's network attached and I just lost my whole network as a part of one of these ransomware wipers, I'm going to have a really bad day. And then look for those ICS specific things. So set points, your project files, engineering documents, where are you keeping those and how quickly could you get those back if you needed to? And then lastly, but certainly not least, test, test, test like it's game day. A lot of folks will say, well, we have backups. And if you say, well, when was the last time you sampled that? Or when was the last time you actually used that backup? You don't have a really good answer. Never. Or I think we did that one time for Y2K when we had to do a failover event. That was great. So you want to be able to make sure that for those industrial control systems in particular, you're having some sort of routine cycle to be able to know that you get back to that last known good state. And this gets us to our sort of final roadmap of stuff. You're going to start off with maybe not understanding everything within your control system, and that's fine. Your engineers may. The engineering role and the OT security and the IT security roles all need to be on the same page for these type of things. So doing things that are really simple at first, architecture reviews, making sure that you have some sort of dedicated team for OT security, that crown jewel analysis, right? What's that really bad day look like? Investing in those perimeters, hardening those systems, getting some backups. You can create a very simple roadmap that gets you there. It may take a while, and that's okay. But I want people to at least start that journey. And then over time, you can get to a more Nirvana-like state where you're actually doing data collection on the norm. You're actually doing OT-based detection where you're looking for actual threats that may be happening that aren't necessarily ransomware per se, but things that may be happening in your control system that you want to know before a bad day happens. One of the things that my peers in the Intel side will talk about is when an activity group is in your control systems, they are sometimes very noisy, but you wouldn't know that if you weren't looking for it. And then lastly, test those things. I love doing tabletop exercises with engineers. It's fantastic because they'll tell you what they will do for their engineering processes, how they get back to reliability, how they get back to a safe system if they had to and they didn't know what it looked like. Where from the OT and IT security perspective, we may not have all that visibility. So being able to do that, do penetration testing that is specific to industrial control systems. Again, if simple tools that we use in IT are deployed in OT, you may have a really, really bad day just doing a pen test. So understanding that you get somebody who understands OT and ICS security, doing the penetration test, and then doing sort of those routine threat hunts as part of your overall OT specific program. If you have any questions on any of this, particularly things that dive into what we've seen from ransomware over the past year in particular, we release every year what we call year in review reports for ICS vulnerabilities, for the threat landscape, and lessons learned from what we do on the protection side of the fence. So these are all free to download. You don't even need to register. You just click the skip if you don't want to register to put your name in the hat, though I think you already did to register for this, so that may be a moot point. And with that, I know that we've got some questions. I see my board lighting up here. And Dave, why don't we go over to figure out what folks want to know?
All right, let's take a look at some questions. Great job,
Oh, Dave, you may be
Jason.
on mute.
Am I on? Can you hear me? I should not be on. Oh, am I on mute?
I hear you, Dave.
Excellent. There we go. All right. We've got some good questions here. Let's start with this one.
If we can unmute.
I think everyone else can hear me, Jason.
I can't hear you.
Okay. We can do sign language. Let me just make sure that other people are hearing me.
I'm not having audio trouble, so I will fix this.
Okay. It looks like our folks out there can hear us, so perhaps Jason's having a couple issues there hearing me. The problem is that Jason's the one who has the answers to these, although actually while he's getting that worked out, there are a couple of these that I can perhaps address based on some of the things that we've been hearing over at the Cyberwire. We have a question here. I'm hoping to hear how buzzwords like COVID-19 and Zoom are being used in the ransom world. I know we've been tracking that the folks who are out there spinning up the ransomware, who are sending out those phishing lures, all those messages, yes, absolutely, they have made a major shift to using those words like COVID-19, like Zoom, and of course the reason is because they work. It's something that's going to grab our attention, and it's going to make us sit up and take notice. So the lesson there, I think, for all of us is on the employee training side of things. We have to be sure to get the word out. make everybody know that when you see those messages come in particular when they have those words, you have to think twice. You have to maybe pause a beat, check with someone else before you respond to something that's going to require any action on your part. And of course, the general rule to not click the links. I know that's easier said than done sometimes. Jason, are we back yet? Can you hear me? Now I can't hear Jason. There he is.
Can you hear me now?
I can hear you now. Can you
All
hear
right,
me?
perfect. Technology is fantastic when it works.
It really is. It really is. Let's move on to our next question here. Is phishing the primary vector that hackers are using to land the ransomware?
Every good story starts with a phishing attack. I mean, it's primarily, you could talk again about the malicious links for sure, but phishing is one of the more popular techniques by far. There's great footage from not ransomware related, but the industrial control system attack that happened in Ukraine that led to their first blackout in 2015, and that started with a phishing attack. It started with an attack that was very targeted. As folks would know, what was happening in Ukraine at the time was sort of there's a geopolitical strife happening. Crimea was annexed, and the operators got an email that said, "Would you like to know about Russian troop movements in your area?" I don't know an operator that would not say, yes, I would like to know that there's going to be something happening in my territory. And you downloaded the link and you got a enable macros Word document. It looked like it came from the official federal government. And so they clicked on it. And so you do find that phishing attack being a really popular mechanism with attackers, but they could also get really, really complicated and really realistic looking.
Here's another question. Jason, does an OT support team back up their OT networks and assets in the same way that IT managers back up their networks and servers?
So it depends on the environment. Sometimes if you're talking about like a control center for like a regional dispatch for a power system operator, the control center will look and feel a lot like a data center. If you're talking about something that's happening at the substation level or distribution in the same exact industry, same exact company even, it will look and feel a lot different. You may instead take down what are the set points for those relays. And to note that down again, like I said, on Excel and on a paper trail, because you won't necessarily be able to get a digital version of a backup. So it really depends on your environment. So your mileage will vary, but there are tools that will do both.
Our next question, we have insurance. Basically, any decision about the payment will have to include them. What is your view on insurance paying up the ransom as almost standard approach?
So this has actually had a lot of drama within the insurance industry. It's been really interesting. Typically, the headlines that you see are, I would not say accurate. You see a lot of folks who I'd say are doing a Hail Mary pass. They'll do something that will invoke their general liability policy. And that general liability policy will almost never cover cybersecurity. And the organization made a distinct decision to not buy cyber-based insurance. So that'll be a lot of the things like, oh, they're bringing someone to court over active war and all these other things. Those are not the type of policies I'd expect to see from an organization that is really looking at cyber insurance. Cyber insurance is its own insurance product. And that product itself will have different call outs for what you'd have to do. So if this already sounds like somebody is dealing with a cyber insurance product itself, you'd have to see whether or not it has limitations on ransomware. I know a product from AIG that will help you out, for example, not to plug AIG, but I just know this product that will actually get a firm to get the Bitcoin to help you out with doing the ransomware negotiation. So there are some insurance products that will get that. If it's something that somebody's worried about and they're going to pay the ransom, then talk to your insurance provider about it. But again, that insurance products are almost like security products. You need to tailor them to your environment and what your concerns are.
Our next question, you talk about the attacks coming from IT to OT, but are you concerned about, say, wireless industrial IoT devices being compromised as the entry point? Maybe not the target, but as a way to deliver malware to higher level systems.
Oh, so that's a good one. So I'm absolutely worried about any entry point into my clean, pristine industrial environment. And I say that a little tongue in cheek because I know they're not always clean and pristine, and I really want them to be. So anytime I see a new connection coming into an ICS environment that we don't manage or control, that we have no visibility into, yes, I have several panic attacks. I'm not so worried about it flowing upstream into the IT. I mean, there could be an interesting, trajectory there, I guess. But it's so much easier just to have somebody from accounting or HR or click on a bad link than it is to worry about the OT going into the OT, not messing around with it, and then trajectorying up. You could absolutely see, I mean, it would be a creative exercise, but I would probably see somebody go both simultaneously. Somebody would want to be able to compromise the IT network via some means and compromise the OT network via other means, because the skill set down here is so specialized. I wouldn't expect them necessarily want to or have the same capabilities as another adversary focusing on IT, if that makes sense.
Our next question says, with the rush to provide widespread work from home capabilities and capacities, will this quick implementation potentially open more pathways into the ICS world? Will this make securing ICS more difficult? That's a timely question.
Yes, I actually wrote a blog piece on this Tuesday, so very timely. Absolutely. So there are also a lot of industrial vendors out there that are offering free remote access software now to their systems. Do not use those without having a conversation about the risks. There absolutely needs to be a conversation within operations. We are worried about reliability first and foremost. When somebody turns on a light switch, they better get power. When somebody opens a faucet, they better get water. So reliability in operations always comes first. But we need to have that conversation about what are the security concerns when we enable something for that to take in consideration. So absolutely, and I could provide links to that blog post in the email. That'd be really easy.
Our next question says, have you seen ransomware in the wild, specifically targeting OT components, such as PLCs, smart devices, and so on?
Yeah, so I can't say that I have. The things that we've seen specifically, the most that I've had the conversation with has been Eakins, where again, it had this idea of these are the industrial process files, the processes we see on servers, on things that would be that, for those of you who are familiar with the Purdue model, which is where we got really nerdy on OT, but I spared everybody that for this talk. If we go into that, that would be sort of your level 2, level 3 devices. We haven't seen sort of anything that goes down to the PLCs. PLCs are really easy to mismanage, right? I can send them a very basic scan or ping, and that PLC has a really bad day. So haven't seen that per se at that level.
Our next question says, investing in perimeter is a good point, but what to do in the case of smart meters as a part of ICS? The adversary doesn't need stage 1 and can just start from the stage 2 and moving vice versa to the IT side.
Oh, yes. So absolutely, smart meters upon deployment, when we first had to deal with these before we did advanced meter reading and we went into full AMI, for those of you who are, I know now I'm going into meter tech conversations. When we started doing smart grid deployments, there was a big conversation to every state regulator and federal regulator about what you're doing to secure those systems. You're absolutely right. We're now putting a device at the edge of the home, and if it's a malicious person at the edge of the home, you could have a really bad day just on that. The perimeter, still critically important. However, when we're talking about what security processes we could do for meter infrastructure that is deployed at the home, there's a lot of conversations about how do I verify the data that I have. That's what we really care about. We care about two things with smart meters: verifying the data for billing purposes and whether or not we're dealing with massive remote disconnects. Those are the two things that you just need to make sure you have additional security processes around to be able to make sure that you've got more confidence in those systems.
We've got time for one more question here, and it's this one. For the IoT challenge, what are the best solutions for discovering rogue or malicious behaving devices in ICS environments?
So, I mean, it's almost a lob to be able to talk about OT detection technologies. It's a hot space right now within industrial control systems. There are several vendors in space. Dragos has a product in that space as well. But being able to actually get a device or get a system in place in industrial control systems that can understand the traffic flow going back and forth. I can't necessarily just take, for example, snort rules, which are a great way to start and understand the context of what a controller is asking to happen or what a operator is doing on that network without having a little bit more context. And that's what those specific tools do. So again, when we talk about, for example, crash override, which was what caused the blackout part 2 in Ukraine, that was very noisy. It tried to figure out what system it was in place, what different protocols it would want to be able to exploit. And if you had something there to be able to detect that going into it, it could lead to a better conversation, a quicker remediation. If you don't, then by the time that you're dealing with that, you're now dealing with incident response. You're not dealing with the left of boom, the preparation stage. So where you have critical systems or the crown jewels, setting up the perimeter, understanding what's inside those, and then be able to detect things that would be happening there would be a great way to start.
All right, well, that is all we have time for today. Again, I'd like to thank everyone for joining us, and of course, Jason Christopher from Dragos for leading the conversation here. Lots of good stuff. We hope you enjoyed the presentation today. There will be follow-up with all of you. You'll be able to view this presentation online in a few days. You can share it with your coworkers and colleagues. We do appreciate you taking the time for us today. I'm Dave Bittner from the Cyberwire on behalf of everyone from Dragos who made this possible. Again, we thank you for joining. Stay safe out there, and we hope to see you soon.